Hi, this is David with Seismic Rocks. Today I'd like to talk to you about endianness and the Seismic Unix program suswapbytes. Well, we might say that endianness is a problem and suswapbytes is the Seismic Unix solution to that problem. But to get started, I want to show you some data sets, and there'll be examples of what the problem is. So from the Seismic Unix wiki, we can get data from here, and this is the Oz Yilmaz 40 seismic shot gatherers, and I could click this, which will open this download button, but I already have this data. So this is big endian format. Okay, there are basically two kinds of endianness. There's big endian and little endian. There's also a bi-endian, and Seismic Unix does not have a solution if you have a bi-endian data set. But we can use suswapbytes to swap between big endian and little endian. Now on the Seismic Rocks website, which is my website, we can go here for another set of Oz shot gatherers, click the image below to download a compressed tar file of the 40 Oz shot gatherers in little endian format. And I would click this to download this Oz dash, we see at the bottom of the page here, Oz little endian tar file. And again, I've already done this. So let's go ahead and look at what we have. I put these into BE for big endian. This is the Seismic Unix wiki data, and the little endian directory LE, and that's from the Seismic Rocks website. For example, LSBE, and there are 40 shot gatherers here, and the tar file that I unzipped. To unzip, I used ZXVF and then file name. Okay, and if we look at the little endian data set, we have again 40 shot gatherers and the tar file that I untarred. Now let's go to this terminal here, and let's change directory to the little endian data set. And I guess I'm leaving out the important thing here and talking about little endian versus big endian. Historically, machines like Solaris and the IBM 360 are big endian machines. And Seismic Unix was created back in the day when there was only big endian hardware architecture. And that's what we're talking about here, is big endian, little endian is the byte order of the data. Well, let's go ahead and use this terminal to go to the little endian directory. And let's use SU range on an example data set. And let's let that be, let's say, 08.su. And we see that we have information. SU range worked. It gave us a printout to the screen, 96 traces, number of samples in each trace, 1350, and the DT, the sample spacing on the trace, is 4 milliseconds. Now let's go ahead and use this terminal on the big endian data. So let's change directory to big endian. And remember, this is the data that I untarred from the Seismic Unix wiki. And SU range ozdata.08.su. And now we have an error. We have on trace number 2, number of samples in header differs from number for first trace. This is the error message that I get when I am on a big endian machine reading little endian data, or on a little endian machine reading big endian data. And that's what's going on here. And what do I mean exactly by that? Well, the Wikipedia has a pretty good article about endianness. It's something that I can't go into in detail because I don't really understand the deep details of it. But in simple terms, endianness is the byte order in the word of data on a computer. Intel and modern day machines that we usually work on are Intel or AMD machines, and these inherently are little endian architecture. In the days of gone past, it was much more common to be on a big endian machine. For example, a Solaris or an IBM 360. Those are big endian machines. But I'm on a little endian architecture, and I want to read this data. So I will use suswapbytes as data.08.su. I'll output this as oz.swap.08.su. And SU range oz.swap08.su, and now I'm reading the data. Very simple. suswapbytes is very simple to use. I don't have to use any parameters on it, and now I can read big endian data. Now I have a data set in little endian format that was formerly not readable. So the big takeaway here is when you see this message, this error message, on trace number 2, number of samples in header, whatever that number is, differs from number for first trace. So this is a problem, an error message that I don't know what it means literally, but I do know that I can recognize the style of this message, and I know then to try to use suswapbytes. Now, if I use suswapbytes and then I still can't use the data, then I can't use the data. That's the answer there. But still, the point of this exercise is to show you this error message and to let you know that this is an endianness problem, and suswapbytes is a simple answer to being able to use data that at first seems like it cannot be used. Now, let me talk about a related problem. That is installing Seismic Unix. You can tell because I've used SU range that I already have Seismic Unix installed. Let me show you this. So my installation of Seismic Unix is in this directory. So let me change over to it. And I'm going to drill down to the source directory. And in this directory, I have a Makefile.config. Now, I made a backup of it here because I did modify Makefile.config. I'm going to use an editor to show you where I made the change. We see towards the top some information. The hashtag here, the hash is a comment. So this is not code in the Makefile.config file. But the XDRFLAG, the variable XDRFLAG is by default set to this. And what that means is it forces all SU data to be big endian, independent of processor architecture. As I told you, I'm on a little endian machine, and I don't want to be creating big endian data. I want to create little endian data. So before I installed Seismic Unix, I came into the Makefile.config file and I commented out this line, same as this line, showing the default way of doing this. And instead I made a new XDRFLAG line which has a space on the right side of the equal sign. That's the change I made before I installed my Seismic Unix. And that way, instead of forcing my data created by SU to be big endian, it lets the data be created in the architecture native format, which, as I'm on an Intel AMD machine, is little endian format. That's the lesson I wanted you to see, is that I wanted you to see the error message that is from an endianness problem, and I wanted you to see how simple it is to use suswapbytes to solve that endianness problem, but also to recognize that in the Makefile.config, I changed the default setting to honor my native architecture of creating Seismic Unix data in little endian format. Well, that's all I wanted to say for today. Thank you very much for watching, and please subscribe, make comments, suggestions about this video, and suggestions for future videos. Thanks again. Bye-bye.